All right, here we go. We're going over the worksheet, so we're not doing a section right here. We're just doing worksheets. What is it, 7-4?
7-4.
Okay, and we're doing page, what, 26, right? All right, so these are the problems that you guys asked about. So this is number 4. So I drew the triangle. They told you that DB was 9. They told you that AB was 27. And let's see what else they told you. CE is 1/3 of EA. That's probably where, let's write it down. CE is 1/3 of EA. This is the part, I'm sure, that messes you up a little bit. Before we even go to this thing right here, let's look up here. I got this whole thing is 27, this little bit is 9, so what can you figure out from that? You should be able to find AD. How do you do that? 27 minus 9, which is 18. Alright, so that's the first thing I would do, because I want to find the lengths of all 4 of those segments. Everybody got me on that? Okay, so look at this. AE and EC. Well, I do know a relationship, but I don't know exactly how long this is, and I don't know exactly how long this is. But I don't really care. All I care about is the ratio. All right, listen. All I care about is the ratio of those two sides. I don't really need to know exactly the length of those sides. I just need to know the ratio of this side to this side. So let's set up a ratio. And it doesn't even have to be to scale. Look, this side right here is 18. This doesn't have to be, you know, close to 18. This could be some off number as long as the ratios are the same. So it says CE, this little bit right here, is 1/3 of EA. So this little bit is 1/3 of this bit right here. Or if I wanted to look at it the other way, what is EA then? EA would be what? If this little one is 1/3 of this, then the big one is what?
2/3 of that.
No.
3/3.
Look. Watch. This right here is 1/3 of the big one. So the small one is 1/3 of the larger one. So that means the larger one is how much more than the smaller one? No, it's 3 times bigger, right? Look, if this is 1/3 of this, this must be 3 times the whole this little bit right here. Does that not make sense at all? I'm not sure how I can explain that better. Let's think. Yeah, but that doesn't help you understand it if I say reciprocal. But okay, watch. Let's think about this. Let's talk money. Everybody likes talking money. So if I had, hush. If let's say if I had, let's say I had $5, okay, and I have 1/3 of what John has, okay. So if I got $5 and I have 1/3 of the amount of money that John has, how much does John have? 15. Okay. So he has what? Does he have twice as much as me? Does he have 2/3 as much as me? What does he have? He's got 3 times as much money as I have. Does that make sense? Okay, it's the same thing with sides. If we can think of that with money, we got to think of that with sides. So look, if this is 1/3 of this, then this is 3 times, right? That's 3 times as big as the little one. You don't have to write it like this. I'm just trying to get you to think, because a lot of people don't like the 1/3, right? So we could make this, as long as this side right here is 3 times as big as this side, it doesn't matter what length we make it. So I can make this anything as long as this is 3 times as big as this. So let's do the little side. Let's just make up. Let's do the 5 and the 15, okay? Again, it doesn't have to be to scale or anything, but if I made that 5, remember, this is 1/3 of this, okay? So that means this big one has got to be 3 times as much as this. So how long is AE if I make EC 5? This has to be 15. Did I have to use 5 and 15? No, I could have used anything. I could have said this was 1. What if EC was 1? What would AE be equal to? It'd be 3. What if this was 2? How big would AE be equal?
6.
It'd be 6 because it's what? It's 3 times as big as this. Does that make sense? Okay, so if the little one is a certain number, this big one's got to be 3 times as big as that. How did I know that? I knew it because of this stuff right here. You got it? Okay. Now look, I wouldn't make this like 20, because if AE was 20, what would EC be equal to? Just give it to me as a fraction. Don't. That's not a fraction. Give it to me as a fraction.
5.5.
Just give it to me as an improper fraction. Why do we hate improper fractions? Quit hating. You guys are all haters on improper fractions, okay? There's nothing wrong with an improper fraction. Look, you should have been able to do it. Listen, hush. You should have been able to do this problem like that. Not sitting there thinking and punching stuff into a calculator and giving me decimals and giving me mixed numbers. If this is 20, how do I find this if it's 1/3 of this?
Divide 20 by 3.
Yes, so what is it? It's 20 divided by 3, right? It's 20 over 3, right? If this was 20, then this would be 20 over 3. But do you want to use ugly numbers like that? No. So I make them divisible by 3. If this is 15, that's 5. If this is 3, it's 1. If this is 6, it's 2. Got it? Okay. My goodness, I didn't think we were going to have to take that long on that part of it. So here we go. If this is 15, this is 5. So let's see if these two lines are parallel to each other. So what do? We set up a ratio. And we should, by now, have an idea of how to set these ratios up. You could start with any of these 4. It doesn't make any difference. Let's just start with 18. All right. So I could compare 18 to a couple things. What could I compare it to? I could compare it to 15, or I could compare it to 9. I'll tell you what. I'm going to compare it to 9. It makes it a little bit easier. Watch. 18 to 9. Now look, off the top of your head, what is 18 over 9? It's 2. That means that AD is how much bigger? How many times bigger than DB? It's twice as big. But this side is what? 3 times as big. Are they going to be in proportion? No, they're not going to be in proportion. Okay? So you could go through the whole thing. You could go 18 over 9 equals 15 over 5. You could cross multiply. But can you do 18 times 5 in your head? I can't. I'd have to punch it into a calculator. Is it 90? Yeah. I guess you could, because 20 times 5 is 100 and then 10 less is 90. Yeah, you could. 15 times 9. What's that? 20 times 5 is 100. You know that, right?
Yeah.
Okay. And 18 is 2 5s less than 100. Right? So 10 less than 100 is 90, right? Okay, anyway. Watch. You could do that if you wanted to. So 18 times 5 is what? 90. What's 15 times 9? 135? Does 90 equal 135? No, it doesn't. So watch. 90 does not equal 135, so this is not in proportion. So guess what? What's true about these lines right here? Are they parallel? Then they're not parallel. So that's what you had to do to figure out if those lines were parallel or not. Let me show you another thing. I talked about this a brief second, but watch. Brett, you were saying, well, that's confusing. I'm confused between... Look, there's 2 ways to see if this is actually true. You could cross multiply. If these 2 products were equal to each other, then these 2 fractions would be equal. Or you could just do this. You could just reduce these fractions, see if they reduce to the same thing. What's 18 over 9 reduced to? 2. 2 over 1, right? What does 15 over 5 reduce to? 3, or 3 over 1. Does 2 equal 3? Of course not. So that's another way you could have checked to see if it was in proportion. Does that make sense? So look, the ratio of this side to this side, this is twice as big as this. This one is 3 times as big as this. So really, if I was to make this a little bit more accurate, what would I do? I'd probably take this, actually. Let's do this. Delete that, sorry. Watch. Instead of going straight down like this, if I went straight down like this, those sides would be proportional. But this AE is 3 times as big, so it's probably going to go like this. Wouldn't you agree? See, now this is 3 times as big as this, and this still stayed twice as big as this. So look, are the lines going to be parallel to each other then? No, they're not. Does that make any sense?
Why doesn't it do that?
Well, because they're trying to figure out. It's not drawn to scale. Not everything is drawn to scale. We've talked about that 100 times in here, haven't we? Not everything is necessarily drawn to scale. You got to go by the numbers to see if that's true. So if I was to be a little bit more accurate on this picture, I would have to draw it like this, because this then would be 3 times as big as this. You see it? This is still twice as big as that. Look at these lines. There's no way that they're parallel to each other. You got it? So that's the reason why if they're proportional, then they're parallel. If they're not proportional, it's going to look more like this, and they're not parallel. Okay, enough of that. I'm getting tired of that. Number 5 is kind of the same thing. We've rehashed that enough. I did number 5 in the other class. So if you really want to look at number 5, go ahead and look at fourth period. But let's get to this one. Let's do number 9. You guys asked about number 9, so let's do that one.
That looks like a
It looks like what? Oh, that one's ugly. What'd you say?
That looks like a music staff.
A music staff, yeah. It's a little bit wide for a music staff, but I guess I can see that. Except there's what, like 5 or 6 lines for it?
Yeah.
What I'm going to do is I want to make sure these are equally distributed. Okay, and how do I know that they're equally distributed? If you look at the problem, they tell you something here. What do they tell you? First of all, they tell you that all 3 of these lines are parallel to each other, so they do tell you that. All right, that's important. And they tell you that this segment, actually that's kind of not tilted the right way. Let's tilt it the way they do it. Sorry, I must have been looking somewhere else. So that looks more like that. Man, I messed this whole thing up. And this looks more like this. Okay, now it kind of looks like it. And they tell you that this segment right here is equal to this segment right here. Now look, I'm not going to put any numbers in here at all just yet. I will in a second. But let's think about what we learned on this lesson. We've taught this before, okay? Look on the YouTube. It's on there. If I have 3 parallel lines right here cut by transversals, and if these 2 segments, this segment and this segment, are equal to each other, that means the distance between this parallel line and this parallel line is the same as the distance between here and here, right? So if these 2 segments are equal to each other, guess what must be true about these 2 segments over here? Nobody's going to guess? Look, what do you think is true about this segment and this segment? They're equal to each other as well. Does it mean that they're equal to this one over here? If you rewatch that YouTube video where I taught this lesson, you'll hear me say almost the same exact words. Okay, so it's not like I haven't said it before. I've said it before on a couple occasions, not too much, but a couple occasions. So this segment and this segment would be equal. They don't tell you in the problem that this and this are equal. They only tell you that these ones on the left are equal to each other. All right? So the geometry that we learned is to understand that these 2 right here are equal. If you understand that, you can do this problem no big deal. So let's put the numbers in. 2x plus 1 is this length of segment, and this is x plus 7. This is 3y minus 8. And this one is y plus 5. Now look, this couldn't be easier. They already told you that these 2 segments were equal to each other. So how would you solve for x? What do we have to do to solve for x here? Come on, it couldn't be easier. Come on, talk to me, please. Look, if these 2 segments are equal, then what do you do with these 2? Set them equal to each other. That's right. 2x plus 1 equals what? X plus 7. And then you solve for x. It's easy. Subtract an x from both sides, subtract a 1 from both sides, and x is 6. You should have that down by now, right? The algebra. So if these 2 segments are equal, what must be true?
These 2 segments are
That's right. The 2 over here have to be equal to each other. That's really the only geometry that you had to know on this whole entire problem. You just had to know that these 2 are equal to each other. All right? And we have a theorem that says that. Okay, look it up. I'm not going to go through that whole thing again. So it's 3y minus 8 equals y plus 5. Now you just solve for y. Subtract a y from both sides, you get 2y. Add an 8 to both sides, you get what? 13. Divide by 2. You could keep it 13 over 2. I would be perfectly fine if you kept it 13 over 2. All right? But a lot of people like to write it as a decimal or a mixed number, and that's fine too, I guess. And it's 6.5 or 6.5. Okay? So either way, I would have completely accepted 13 over 2. Why bother doing more work? You guys always want to do less work, don't you? Okay, I do. All right, I want to do the least amount of work. I mean, I really do. So I would just keep it 13 over 2, and that would be perfectly fine. But some people don't like it like that, so turn it to a decimal if you want to. All right, that's enough of that. That's pretty easy, isn't it? All right, I think we only went over that one time in class, but again, I go over it once in class. Does that mean that's the only time that you could ever hear it?
Nope.
No. Where do you go?
YouTube.
YouTube.
Or Khan Academy.
I can't believe that I have to twist your arms to go onto the computer because you guys are on there. I know you guys are on the computer all the time.
No, actually, seriously.
Kermit? The worksheet you got?
Yeah.
That was our homework for
Yeah.
tonight?
For last? Oh, the one. Yeah. The one I gave you today? Yeah, yeah. All right, here we go. Here's the picture. Now, this one's a little bit more complicated than what we had done previously, but I don't think it's going to be too bad. Let's see what we got. Up here is, let's see. Oh, they tell you if those two are equal. Let's change that line right there.
Is that Caribbean blue?
Don't know. They say that the midpoint, let's see. Let's put it in the right spot. About right there. Right there. Okay, that's all they tell you. And this goes about like right. Okay, that's a little bit more to scale according to the picture. All right. They tell you that this segment and this segment are equal to each other. Do you see those little tick marks on there? Look for those because that's important to know that those two are equal to each other. And this is 2y minus 1. And this is 3y minus 5.
So easy.
Is it?
All you do is set up equal to each other.
X plus 3. 3x plus 2. Or 3, what is it? 3 halves x plus 2. And they also tell you that these are parallel. All right, let's take a look. This is not the 3 parallel lines cut by 2 transversals, though, is it? It's an actual triangle. So, but look at it. What's the ratio of this side to this side? I don't care what the length of it is. All right, if I just see a little tick mark here and a little tick mark here, what is the scale factor? What is the ratio of this side to this side? It's anything over what? Itself. So, for instance, if this was 7, what would this segment right here be? 7. Why? How do you know that? Because they're equal, because the little tick marks say they're equal to each other. So if I compared this side to this side, I would compare something to itself. What's anything over itself? It's 1, isn't it? So what's my ratio? It's 1 to 1. Which means, what does the ratio over here have to be if these are parallel lines? It's got to be 1 to 1, which means what? It means that this side is equal to that side. All right? So that's all you had to know. That's really the only geometry in order to do this problem right here. And now you can set those two equal to each other and solve for x. Brett? No, wait till we're done here. Let's do this. X plus 3 equals. Now, we have a fraction here. Fractions have a tendency to freak you out. So let's try to work with it. So, tell you what, if you wanted to, well, it's already improper. A mixed number or a decimal, I guess. In this case, I'd probably agree with you. Okay, that this is 1.5, isn't it? So I guess that would be fine. So what do? Let's do this. The bigger number is over here on the right, so let's subtract the smaller one. I like to do that to keep them even. Or to keep them, not even, but keep it positive, okay? So watch, that cancels out, so what do I have here? 1.5x minus 1x is half x. Or, I'm just going to write 1/2 x. Is that okay? That doesn't bother you, does it? 0.5x, 1/2 x, same thing, right? So what do we do now? When we put the numbers on the left-hand side, how do I get rid of this plus 2? Thanks for playing along, guys. I subtract a 2 from both sides, and so I get a 1 right here. How do I get rid of this 1/2? You could divide it by a half, but it's a fraction, so what do we times it by? 2. Multiply by 2, right? Because look, they cancel out, right? That's the whole idea. So what do you do over here? Multiply that by 2. What's x equal to? How about 2? It's times. Multiply. All right, so x is equal to 2. That wasn't hard at all, was it? All right, so that was x. And now you just do the same thing for y. Look, y is really simple. 3y minus 5 equals 2y minus 1. Subtract y from both sides, you get, or sorry, subtract 2y from both sides and you get y. Add a 5 to both sides and you get, what's negative 1 plus 5? It's 4. There's your answer right there. 2 and 4. Okay? So that was number 10. Is there anything else? We've got a couple more minutes here. I think we pretty much covered it all, didn't we? We didn't do 6, 7, and 8. But yeah, I think you see that. I don't think it's too hard. All right, so your worksheet is page 27. I'm sorry, your homework is the worksheet from page 27. So this was, oops. Okay, Page 26 was this worksheet. Tonight's homework is what? Page 27 worksheet.
We don't have to do number 9.
Listen, tomorrow I'm going to collect 3 things. Guess what I'm going to collect? Page 26 worksheet, 27 worksheet, and then there was from the book. Right. There was section 7.4 from the book. All right. Where at?
I ended up
For which one? For x? Well, 1/2 x is 0.5. Like 1.5x minus 1x is 0.5x, right? So you would get this. You would get a 1 equals 0.5x, right? I would rather, hey guys, I'm still helping somebody out. So I like to write it as a fraction because I think it's easier to get rid of the fraction than it is to get rid of a decimal. But you could do this. You could divide by 0.5, divide by 0.5, put it into a calculator, and you get 2. All right? But watch, it's 1 divided by 1/2. What's 1 divided by anything? It's the same thing as 1 times the reciprocal, right? 1 times 2 is 2. I think it's way easier, instead of writing 0.5, I think it's a lot easier writing at 1/2, okay? And then solve it like that. Okay, so 3 things tomorrow. Make sure you turn all 3 of them in tomorrow. There's the book, there's 2 worksheets, and then we'll be able to move on to the next lesson.